Third generation partnership project 3GPP. Right. See, earlier we have studied about ITU, correct? What is ITU? International Telecommunications Union. So the hierarchy is TRI, IMT, correct? But where this TRI will comes under this will comes under ITUT, correct? Okay. So from the TRI, then it goes to IMT, okay. From IMT, it will goes to DOT. DOT is nothing but Department of Telecommunications. So hopefully this BSNL will operate under this DOT. Okay, so this Department of Telecommunications, what they will do is, they will insist all telecommunication companies to work under this DOT. Right, so you can see cyber security, okay, and some outreach program is there that they are conducting this DOT. I have on PPT also, I showed it PPT. Right, so ITUT, then TRI, IMT, then IMT comes under, not comes under, IMT, then DOT. Correct? Okay, so DOT is your Department of Telecommunications. I'll show that in slide. So this ITU, which is classified into ITU R, T and D. Okay, so what is R is radio communication. This will manage RF spectrum, satellite orbits, and ensures interference-free RF communications. See, normally, who works under this part, and who works under this part, and who works under this part, we are going to see. But we are going to study detailedly about this. Right? Okay. What is ITUT is? Telecommunication. Okay. So it defines tariff principle. Tariff principle is, if Jio wants to increase the subscription or wants to decrease the subscription, okay, they have to go via IMT via TRI, and TRI to ITUT. So this is global standard, not especially for India, right? So this is one, the hierarchy it follows. And the next is your ITUT, that is your infrastructure development. So infrastructure development is nothing but how your equipment is developed from 3G to 5G. Equipment is nothing but, I told you, the components which is present inside the core network that is evolved during your generations. Correct? Earlier they have adaptive signal processing in the base station, that is in 4G and 5G, but 2G and 3G they have a different base station. In that base station they are processing all these signal processing equipment. So what is the signal processing? Your analog signal will be converted to digital, and sampling, quantization will be done in that. Okay, so that 2G and 3G they have a separate infrastructure, but when it comes to 4G and 5G, that will be placed inside the base station tower itself. No need to go for extra infrastructure. So that will be done by using this standards ITUT. And next, if you go for 6G, what type of extra components or features to be added, that will be defined by this ITU. Right? Okay. So this is your ITU. In this ITU, we are going to focus on this ITUT, this standard. Right? So before going to that, you should know what is frequency allocation. I think I have explained in the first class itself. Right? Your 300 GHz, 30 GHz, everything. Have you noted down this? Right? So, which is your high frequency here? Have you ever seen that how microwave oven is working? That is millimeter waves. Microwave, they are using millimeter waves. I'll tell you what is millimeter waves. Right? So when you are heating some food, right? So they are going to produce an extreme high frequency. With that frequency, this by using total internal reflection, your heat is developed. That is going inside this microwave oven. Correct? So they are using extreme high frequencies over there. That frequency ranges around 30 GHz to 300 GHz microwave. Okay, and this is used for millimeter waves also. I'll tell you what is millimeter wave. Okay, so then this 5G is supported by 3GPP. So 3GPP is one of the standard they have evolved starting from 2G to 5G. So 3GPP is nothing but third generation partnership project. So what does this mean? All countries together, okay, they want to develop a generation wise technology. Like from second generation onwards, say for an example, Europe, US, China, Korea, and one more country, UK. Okay. Later, India joined this around 2019. Okay. Those four big countries, okay, they want to involve in this generation, and if any next development or technical development is there, that will be done by using this 3G. So this 3GPP, all these 5 countries have developed this 3GPP. Okay, so whatever, say for an example, if USA is doing some technological advancement, they have to tell to all these 5 countries which comes under 3GPP. So they will implement this, and they will again simultaneously they will propose it during some years. Able to understand? If any company is doing their project, okay, so any country is doing that, technology development, that should be involved by all 5. Right? So 2019, India has also joined in this 3GPP project. So we are also one of the market leader in 5G. Right? Few countries are there, they didn't see it about 3G, 4G and all till now. Any countries you know? North Korea, they are doing illegally. They are using this 5G also. Some African countries, okay, and few Arab countries also, they have not implemented this 5G so far. Arab means not that Arab, like Pakistan, Uzbekistan. But so these are the countries, they are not involved in this. They have not developed their 5G. But India, along with all these 5 countries, okay, the technological advancement is now heading towards 6G. Right? Okay, fine. So next, you know what is low band, mid band, high band. On the first day itself, I told you what is low band. Low band frequency range.
700 megahertz.
I don't see that. 700 to, not 700, 900 to 1800 megahertz is your low band. Mid band is around
3.32.
that is high band. Mid band is 2100 gigahertz to around 3000 gigahertz. Then high band is your 3.3 gigahertz to 3.6 gigahertz. Okay. Then extreme high frequency band is there. That is greater than 26 gigahertz. So extreme high frequency, they are focusing on 60. Right? Okay. Okay. So that is what they have divided into two bands. One is FR1 frequency, band 1 and band 2. So this is your, what is FR1 band? This is your low frequency band. That is, we can call this as sub gigahertz band. That means sub 6 gigahertz band. Less than 6 gigahertz will be called as FR1. More than 6 gigahertz will be called as FR2. Right? If a customer needs FR1, they automatically switch this to FR1, and customer needs FR2, it automatically switches to FR2. That means if any voice call, anything related means automatically it switches to FR1. If you need a live streaming video, anything means what, it will switches to FR2. Right? So this code we can call it as cognitive radio technology. So cognitive radio technology is nothing but, if you have two frequency band, okay, if one is used, some people wants this video streaming, right? They will use the second frequency band. If some people is using this, some people wants to use voice call means they can use this. But earlier we don't have this kind of strategy. Okay, so all these will together one frequency band. Okay, so if more subscriber wants to approach this band, they will be in a queue. Okay, so based on the customer needs, they have divided into two frequency bands. So FR1 and FR2. Those who wants to go for a low data rate, they will go for FR1, and those who want to go for a high data rate, they will go for this FR2. Correct? So this mode of approach we can call it as cognitive radio mode. Are you able to understand? Right? Okay. Now we'll see the key technologies of 5G. Okay. One is millimeter wave, second one is MIMO, third one is repeater, fourth one is device to device communication. Okay, because of all these four only, this 5G is developed. Right, the first technology is what? Millimeter wave. What is millimeter wave? The name itself, it specifies centimeter wave, millimeter wave. Millimeter means whether the distance is shorter or more? Shorter, correct. So, if the distance is shorter, what is the frequency? High. Wavelength? More or less? Less. Correct. So, if you are using higher frequency, automatically your distance is lesser. Right? That is, your wavelength is lesser. Correct? So millimeter wave is especially used in 5G technology, and how this is implemented we are going to see. Okay, say for an example, you know how a call is made from one base station to another? Any idea?
Routing.
Stop. See, this is your 2G architecture. Now it is 5G architecture. So before going to the 5G architecture, you should know what is happening inside this. What is the year 2G? 1990s, correct? So 2G is your which architecture? What technical name we can call it as?
GSM.
What is GSM? Global System for Mobile. 2.5G?
GPR.
General Packet Radio Service. GPRS. Correct? Okay. Now we'll see. See, a person who is sitting inside a car, okay, he is having mobile phone. Okay. So the car is moving at a faster rate. Okay. So the person who is going to initiate a call, he wants to connect to the external network of any landline, that is public switch telephone network, or any other receiver who is having a mobile phone. He is also maybe sitting in a car. Right? How this call process will take place? First, this mobile station will initiate a call. This will go to the base station. So this is called base station. Okay, so this base station will have BTS. Okay, that is base transceiver station. So base transceiver station is nothing but what is transceiver?
Receive, transfer.
It can receive and also transmit. So what it will do is it will receive the signal from mobile station, then it will transmit to the MSC. MSC is your mobile switching center. Okay, so what this mobile switching center will do is this will forward the call to HLR. This we can call it as home location register. Okay, I'll tell you what is this home location. And this is visitor location register. And this is authentication. Right. Now what happened is once the call reaches MSC, this MSC will act as a router here. Okay, so but this is the heart of the system, heart of this entire architecture, 2G architecture. And this will forward to HLR. So HLR is nothing but home location register. This will contains the permanent database of each subscriber. Okay, if a person is calling from Geo network, okay, so this information will be stored in HLR. So what type of person, not what type of person, it's not behaved at all. So what type of service, you have a 2G service, and what type of network you are having, everything will be stored in HLR, home location register. Okay, and this, when a person, I told you right, this car is moving at a faster rate. Suppose he is moving from this Chennai to some other place in Andhra nearby, right? So what will happen? This call will be given transfer to VLR. This is called roaming. I think you people have heard about earlier days. Earlier days we have to pay paisa for that roaming. Okay, nowadays only there is no paisa for roaming, data roaming. Correct? So what will happen is when they are moving from one particular location to another particular location, say for an example, one state to another state. Okay, so it is moving to VLR. So VLR is your temporary location register. So what it will do, it will contain the database of a temporary visitor. Okay, but he is from HLR only. Okay, the permanent database is HLR. But suppose he is moving from one state to another state, the information will be stored in VLR. From the VLR, it will take, okay, where the person is, okay, in which state, okay, and now automatically it's changed to roaming symbol. Right? So once everything is done, it will given to authentication. Okay, so if you want to initiate a call, this call will request up to this. Till now your call is not connected. Right? It is in the requesting process, call initiating process. This will happen within a millisecond. Right? From this authentication, again it will given to MSC. Okay, so what this authentication will do? Okay, everything is verified. He is from HLR, but now he is moving to another state. So his information is stored in VLR. You can give permission. He is an authorized user. That type of authentication will be given to MSC. Okay, then from MSC, it will again goes to base station. Okay, so base station, the process of handling the transceiver. Again, it will receive from MSC. It will transmit again to mobile station. Now call initiation request is completed, acknowledgement is completed. Now only then the call process will take place. Okay, so this will happen within a second. That is my millisecond like this. Okay, so this is the back end process of architecture. Okay, so after this call is initiated, it will go to the base station, then base station to MSC. MSC will direct to the external network. External network, either you are going to connect it with the landline or another mobile at the receiver end, or if you want to access for any data, that will be your external network, that is BSP. Right? So this is 2G architecture. Okay, and this is basically followed architecture. Before that, we don't have any architecture in 1G. Okay, 2G only they have defined this architecture. And from 3G, 4G, okay, with the same architecture, they have done few modifications, like inserting extra feature over here. But the architecture is same. The basic architecture is same, right? And in 5G, they have changed this entire architecture. They have introduced new features. They have removed this architecture. So, if you want to connect a call for a 5G from a mobile station, it will go to the base station. At the base station itself, you have, I told you, right, adaptive signaling processing, which is present at the bottom of your base station itself. So, half of the work has been done in this part itself. Okay, then it will move to the architecture core network. So, this is called core network. I told you right yesterday. So, this is called core network of 2G. And we'll see what is the core network of 5G. Okay, they have removed all these and they have inserted a new core network. Correct? We'll see that because that is your main thing in your syllabus. We are going to study detail about that 5G. Right? So this is basic how your call will take place. In that, I told you right. First is millimeter waves. Okay. If it is a millimeter wave, consider this is a mobile station. Right? If it is not a millimeter wave, I can go for GSM architecture like this. Why? Because this uses low frequency band. That is 900 to 1800 megahertz only. Right? So that is low frequency band. So it will travel for a longer distance. But it carry less data only. So that is what, if you are using any data in 2.5G, 3G and all, you can see how much time it will take to upload or download a video, or to see a video, or to see an image, even image itself. Okay, this will take much time. Okay, but when it comes to millimeter waves, the infrastructure should be developed. So this infrastructure will be taken care of, this ITUD. What is that infrastructure? So infrastructure here is, instead of placing a bigger base station here, we have to deploy smaller base station or smaller tower. Why? Because here millimeter waves means we have to use higher frequency. If it is a higher frequency, I told you, your range will be less, your wavelength range will be less. So you have to cover a more area, means you have to deploy a smaller tower over there. Right? Say for example, from the mobile station, this is millimeter waves. Okay, so each 10 meter you have to deploy a smaller base station or smaller tower, we can call it this. Right? So each 10 meter you have to place like this. So what this tower will do? This will receive the signal, then again it will boost it, then it will give the signal to the next the small tower, then again boost it, small tower. What is the drawback of this millimeter waves is, we have to deploy more infrastructure. That is, more base stations and more tower has to be deployed. But it can carry more data at a higher rate. Right? That is what millimeter wave will do. So what we have to do, there is a trade-off. Correct? What is this trade-off here? When I use this, I can carry lesser data but a longer distance. When I use this millimeter waves, I can have more data at a shorter period, but I have to deploy more number of towers within a 10 meter distance. Correct? So now the research is going on this part, millimeter waves. What research is? I don't have to plant a more number of base stations, okay, when I'm using this millimeter waves. So what is the strategy to reduce this? Are you able to understand? Correct? You have any strategy, you can also tell me. That is the research part now. Right? So if you have any strategies, we can do like this, or we can implement like this. That is one of the technology. This is one, right? So how many techniques I said? One is millimeter waves. So you have seen the advancement but there is a drawback over here. And second is MIMO, multiple input, multiple outputs. The name itself it specifies multiple input antenna, multiple output antenna. Okay. Earlier 2G phones, 3G phones, we have SISO, single input, single output. Now your phone is equipped with MIMO. Okay, that means you have 2x2 MIMO, 4x4 MIMO, 8x8 MIMO, till 8x8 we have as of now. So that means, consider this is a tower and your antenna which is placed over here. Correct? So this antenna is equipped with MIMO. And this MIMO will have 4x4. That means 4 input, 4 outputs. So this is at the receiver end. You have this MIMO antenna 4. Okay. So instead of sending a single data, okay, we can parallelly send more number of data within a shorter duration of time. Correct? Right. So for that purpose, we are using MIMO. Earlier, we'll have single input, single output. So only one information has been sent from transmitter antenna to receiver antenna. Now, parallelly, simultaneously, we can send more number of information within a short period of time. Right? So this is another technology in improving your data rate. Okay. So this is second technique used in 5G. Right? So these are all in deployed stage only. Okay. Then third is, what I said third? Third is beamforming. So now antenna subject you have studied now this semester. Okay. Now only you are entering the communication. Right. Okay. Beamforming is nothing but, see, you have just understand the basics. You have two antennas, basic antennas will be there. One is isotropic antenna, another one is directive antenna. Okay, so these are antennas which is placed on the top of the tower. Okay, so this is a tower and the antenna is your isotropic. Say for example. So isotropic antenna which radiates or emits waves in all the directions, 360-degree directions. Right? But when I see, here is the transmitter and here is the receiver. And this is also equipped with isotropic antenna. Okay, so this radiates in all directions, but I need to send the signal from transmitter to the receiver. Right? Only few part of waves will reach as the receiver, correct? Because it emits waves in all the directions. Okay, so I just want to reduce this because my signal strength will get decreased when it transmits over a longer distance. Right? So in order to overcome this drawback, we are going for directive antenna. So directive antenna is nothing but the antenna which is directed to a single line path. But one condition is both the transmitter and receiver should be in the line of sight. Correct? If it is not in the line of sight, you won't get this. Even though if you are placing directive antenna at the transmitter and receiver end, you won't receive that much of signal strength. Signal strength is nothing but whatever the transmitter you are sending the signal, the same should be received by the receiver. At least, okay, because due to some interference, less than, for example, 100 dB of signals will be sending, at least 90 should recover, right? 10 maybe you can lose due to interference. But when I receive 50, there is no purpose of sending the signal, right? 50% of the gets lost. So when I use this directive antenna also, okay, when these transmitter and receiver is not in the line of sight, okay, they are going for beamforming technique. So this beamforming technique is especially one of the third technique which is used in 5G. Okay, name itself specifies beamforming means, you see here, So this is your a person having mobile station, having mobile phone who's sitting inside a car. Right? He's having a mobile who's sitting inside a car. Okay. So when I use this beam forming technique, what this will do is it will form a beam from the antenna. It will form a beam like this. Okay, in different directions. Right? The person who is sitting at the operator room, he will check, okay, which beam have maximum power. That means a person who is up. Okay, so I told you, right, this is beam. Consider this is beam 1, beam 2, beam 3, beam 4. Right? So, which is having a maximum radiation, maximum target achieved? 3. So what they will do is, they will keep this 3, okay, and they will remove all these beams. Instead of wasting all, see, for isotropic antenna you have 360 degree, right? So it will emit in all the directions. But whenever it is focusing on a particular area to focus on the particular subscriber, okay, it will remove all these and it will focus on this. This part we can call it as beam forming. Okay, yeah, right? Are you able to understand what is beam forming? Right? And fourth last technique is your D2D communication. Device to device communication. Any real-time example of device to device communication? Share it. Bluetooth, connecting your laptop device with your phone. Okay, then this smart fan, you can control via remote drive. Then any other things, you can control fridge, washing machine, everything. So that is called device to device communication. So device to device communicate has to be happened in this 5G technology. How? Device to device. See, take the Bluetooth example. So what is the frequency range of Bluetooth? That is very important. You should know that. Frequency range of Bluetooth is 2.4 gigahertz. And distance? Very less. Count. Value. 10 meters. Okay. So 2.4 gigahertz. Okay. 10 meters. Now you can see where we can relate this. 5G now. How? Higher frequency, lesser distance. Correct? So with this Bluetooth, I can connect. Maybe this is TV, and this is laptop. Another mobile. Likewise, I can connect, right? With a range of the frequency of 2.4 and the range of 10 meters. here, right? And this is happened in 4G also, but with 5G I can connect more number of devices. More number of devices within this 10 meter. So that is the purpose of 5G. Able to understand? What is the first technique? Millimeter waves. Then MIMO, beam forming. Then D2D, device to device communication. Right? These are all the techniques which is currently in research. Okay, if you want to do any research now, you can take any of these techniques, you can do research and you can do some modification, you can publish a paper, you can do a patent. Right? Okay. Next is 5G enablers. Okay. What's the time? See, last week we went to Department of Telecommunications with third year students. You are also third year, right? Okay. So few people who showed interest in this Sanchar Bharat Mudra. Okay, that means this Department of Telecommunication will be giving some awareness program related to cyber security and this EMF radiations. Okay, so I think you people are well aware about this cyber security and all. Okay, so we will just give this outreach program to any schools, okay, villages, like say for an example, don't touch this link. If you touch this link, your money will get lost. Okay, so that kind of thing. And second thing is especially about EMF radiation. Okay, so this EMF radiation, say for an example, if you are planting a tower inside your building, so many people will tell you, right? See, don't give rent for this planting a tower on your building. See, this Department of Telecommunication, they are approaching, not Department of Telecommunication, the service provider. Say for an example, Jio. Okay, Jio wants to plant a tower, okay, on the top of your building. They will be paying rent for you, 50,000 something. Okay, but few people, okay, they don't know. Some will tell this, okay, that roaming. What is that? If you plant a tower on the top of your building, the radiation will affect you. The radiation will affect your health. So this will be a big hazardous for you. Like this, you people have heard something related to that, right? So that is not exactly true. Okay. So that awareness also we are going to conduct tomorrow. If you are interested, you can come and sit. That is for 1 hour only. 10:30 to 11. Sorry, 11 to 1. Okay, it's 11:30 to 1. Right. So that type of awareness we are going to give. We are going to start from our maintenance team is there, right? So we will give this awareness to starting with this maintenance team. Then we are going for schools, villages. Okay. So if you are interested, you can also join with us. That is purely based on telecommunication part. Okay. So by conducting this, we have to post in social medias so that Department of Telecommunication and the Ministry of Telecommunication, they can see your faces also about this outreach program. Right? So based on your interest, you can give. Simply you have to expose, and this should be in your native language, because people in and around here, mostly they won't know English, right? So if you are interested in speaking in Tamil, Telugu and Hindi also fine, because all are mixed up here, right? That's what I'm telling. Fine. Okay, so that is what this is the first assignment they have given for us, Department of Telecommunication, and this. There. Okay. So, and the second part is, I told you, right? SRM is one of the institute. They have provided this 5G lab. Okay, equipments, everything will be provided. So it is there. And opposite to that, a Nokia lab will be coming soon, probably the month of Feb first week. Okay, so Nokia lab, people from Nokia will come over here. They will give you the problem statement. So with that, anyone is interested to work with that problem statement, and you can produce as an output. Okay, they will be providing internship, then finally it will be converted into a job offer. Okay, so anyhow, before that, we people will go for a Nokia industrial visit at least once or twice for this course, because it is industry professional elective. And one of the topic, any hands-off session, will be conducted from Nokia expert. Either from Unit 3, hopefully from Unit 3, two topics will be conducted by Nokia. Okay, so Nokia only proposed this syllabus, 5G syllabus, 5G1 syllabus, right? Based on the industry needs. If you are well versed in these, you can able to go for it, right? Okay, so that's what. So details about EMF radiation. What is EMF? I think you people have studied that subject. What is that? I think you have studied theory part, right? Derivations, everything. Correct? Okay. So EMF is nothing but your electromagnetic waves. Correct? So EMF concerns are based on a perception, fear of unknown, hearsay, but not based on scientific examination. So this is an example of people who is worrying about planting a tower on the top of their building, right? And I think you people have heard about when it comes to 5G, the birds will be dying because of this 5G, right? I think you have seen one movie, Indian 2.0. Correct? That is not true, right? Actually, you have two types of radiation is there. One is ionizing radiation, another one is non-ionizing radiation. These 3GPP standards, that is your 1G, 2G, 3G, 5G, 4G, 5G, will comes under non-ionizing radiation. So it won't affect health. No health hazards will be there when it comes to this non-ionizing radiation. Ionizing radiation will cause some effect on the human, because I'll show that slide. So this is what electromagnetic waves from telecom tower, that is your tower, right? So it is low energy, insufficient to cause effects, and no chronic cumulative effects, safer to health. Examples include radio wave, it won't affect, either it is 4G, 2G, 3G, anything is there, okay, it won't affect the human health. But waves from medical equipment, these are ionizing radiations. So example, X-ray, scan, you are doing it at medicals, right? That is in hospitals. So waves from medical equipment, sufficient energy to alter chemical bonds and atomic structures. So confirmed health effects include genetic damage. Effects can occur from cumulative exposure. Example include X-ray, gamma rays. So if you have any issues related, if you want to go to take X-ray means, they will tell you to take your mobile phones, everything, right? So the radiation will affect this, right? So that is, if you are going for 5 to 10 minutes, that is not a problem. But you are be there for 24 hours means, surely it will affect them. You can see the people, those who are there taking X-ray and scan, they will be wearing one suit and also mask. I think you people can see. That will affect health. Right? Right. So this is who, and this IC, NIRP, they have declared this. Not that much content here. And show that ionizing and non-ionizing. You know what is WHO, right?
World Health.
World Health Organization. Who is funding the World Health Organization? Who is the main funder? Mostly all European countries, USA, India are also funding. Who is the main funder? Now they came out of that. First USA, right? Then after Trump became president, okay, so he came out of that coup. Now the biggest funder is China, right? So according to GDP growth, India is in which position? GDP economic growth. Now it is in fourth, but a few months back it is in fifth. We overcome Japan. Japan in fourth place. Now third place is Germany. Within a month, okay, we can overtake. But 1 and 2 we can't do that. But ours is 4 billion. Okay, and this GDP growth. Japan is 3.9. Point 10 is different. And Germany is 4.5 or 4.3. So that is nearby. But next to that, second place is China. It's around 20 to 25. And first is US, that is around 40, 50. Okay, so biggest GDP growth is USA and China for our wages. So how many of them knows about BRICS? BRICS. What is BRICS? What is B? Brazil. R. Russia. I. India. C. China. Yes. South Africa. And not only this 5 countries, now again 15 countries have included in the BRICS. Right? Example, Saudi Arabia, Japan, and these countries also added in the list. Sir, what is the purpose of making this BRICS? Yes. So far we are trading, whatever the trade happened between the two countries, we are using only dollar. Correct? So when we are using this dollar, automatically America will go rise and we will go down. Okay, because dollar is American currency, right? But in order to overcome these 5 countries, they have initiated this first project, this called BRICS. And what they will do is, they want to do the trade, okay, they have to use their own money, own rupees, okay, own currency, sorry, right? So if India wants to trade with Russia, they will pay rupee, and Russia wants to send something to India, export, import, they will do with their own currency. But earlier it is based on dollar only. So when we do like this, within a part of 1 or 2 to 3 years, dollar will weaken or their particular currency will grow up. For that strategy only, they have developed this BRICS. And because of this, I think few people have heard about Greenland, what Trump is doing about Greenland, what Trump is doing about Iran. Why they are choosing Greenland? More resource like minerals, okay, oils, and mostly is available in that Greenland. Only 20% is occupied in Greenland, 80% is vacant land because it's frozen area, fully covered with ice. But the name itself, it's controversial. Greenland is fully covered with ice, Iceland is fully covered with green. Like that. So Trump's target is Greenland now. Okay. And also, second thing is, not only that minerals, root, sea root. So once he captures this Greenland, okay, there is a sea route will be there, that whole sea route will be controlled by US. So if any country wants to cross over this, they have to pay a toll, like toll tax. So for that purpose also he is doing that. And also this European countries, right, they are opposing this. Again, Trump started their gambling. So if you are stopping this, and put 10% tax on you. But that European countries are the best friend of US. But now it's changing. They have allowed, so far, last 20 to 30 years, we don't have any trade policies with Europe. But nowadays, they have opened a trade, they have signed an FTA, foreign trade agreement with India, these whole European countries. So that is the alternative market of US. Okay, US has imposed a 500% tariff to India, threat, but not implemented. So India changed their plan. So we are not focusing on US, we are focusing on Europe. Right? So that is what the thing. Why Trump gets angry with Modi is whenever this Trump threatens Modi won't react anything. He will change their plan and he won't obey those orders from the US. That is what they are putting tariff again and again in India. But anyway, and what is this Iran plan? Iran plan also, there is a big riot is happening in that Iran due to that president, right? So with that, what this Trump is thinking is, we can go for it, we can capture Iran also, there is a lot of minerals is also there. But Russia will come back in support of Iran. So if Russia comes, US won't enter there. Because the two big military powers there, US and Russia. Right? That is what. Right, so towers are safe. Correct? Okay. Safety standards, everything. Okay, if you have many towers near my residence, will the radiation exits? No. Okay, so this is approved by DOT. So you also, if you have any layman is there, okay, you can talk to your language and tell that this won't affect your health radiation. If your tower is nearby your house on the top of the building, okay, it won't affect for sure, you can tell them. Okay, that is by giving awareness. And that is what. Snakes, beehive, birds nest, birds. There is a controversy, like due to this radiation, all these animals have died. Okay. Sparrows, birds, that radiation won't affect any animals, even a small insect also. Okay. So Father today, see, they gave this presentation. Who? DOT. We had a meeting last week. No. But snakes are a bit too much. Connect, educate, innovate. This is logo. Right. So it's time. Gap it. Just pause. 5 minutes.